Hello friends and welcome. Our today's experiment is to verify the truth table of D-Flipflop and T-Flipflop by using TinkerCAD. Okay, so friends, basically we are designing D-Flipflop and T-Flipflop by using master slave JK flip-flop. And for this purpose, we are using IC 7473, which is acting as MSJK flip-flop. Okay, so friends, one by one, we will design these two flip-flops by using TinkerCAD. So first of all, take a look at the circuit diagram. So this is your D input and here you can find there is S and R input. It means we can design D flip-flop by using SR flip-flop as well as JK flip-flop. But if you look at the T flip-flop, it can only be designed by using JK flip-flop only. Okay, so in our case, we are designing both these flip-flops by using only JK flip-flop. So for this purpose, we are using this IC. Now this IC is dual JK flip-flop. So at a time, we are needing only one flip-flop. Hence, out of these two flip-flops, we will use only one flip-flop at a time. Okay. So friends, go to tinkercad.com and click on create new circuit. So a new blank circuit will open. On the left hand side, you can find various components available. So we will quickly drag required components for our circuit like this. So friends, now you can see we have taken all the required components. So basically we will need a JK flip-flop IC. In order to design D flip-flop, we will need a NOT gate IC, which is IC 7404, also known as inverter IC. Then in order to apply the input, you can use either slide switches or you can use DIP switches like this. In order to apply clock signal, we will need function generator. And in order to power this circuit, we will need a 5-volt power supply. Okay. And to check the output, we will need a LED and a current limiting resistance, which must be of 330 ohm. Okay, so these are the required components. Now let us start with the power supply connections. So friends, here you can see I have connected positive on this lower wire because this is our positive wire. This rail will indicate positive power supply and the upper rail will indicate negative power supply. So positive and negative we have connected. Same lines are available on the bottom side as well. So I have connected the ground from top side to bottom side and similarly VCC. So red line will indicate VCC and black line will indicate ground. Okay. Now in order to do the connections, we will need the circuit diagram. So I will open the circuit diagram in the left hand side. So friends, here you can see we are having only single input D, which is directly applied to S input. Now instead of SR flip-flop, we are using JK flip-flop. So we will connect D input to pin number 14 of JK flip-flop and same input is applied through a NOT gate to K input means pin number 3. So we have to use a NOT gate in between, which means we have to use IC 7404, which is acting as inverter. Okay. Now, before doing the IC connections, let us connect the power supply pins, means we have to connect the ground and VCC. So here you can find pin number 7 is acting as ground, pin number 14 is acting as VCC, whereas here pin number 4 will act as VCC and pin number 11 will act as ground. So we will connect the pins with ground and VCC respectively, like this. So now power supply is connected. Now let's connect the clock signal. So remember, negative of the function generator must be connected with negative line, whereas positive must be connected to pin number 1, which is acting as clock signal. Okay, like this. So friends, now this blue line will indicate the clock signal. It means we have connected the clock signal to pin number 1 of your JK flip-flop. Okay. Now from the block diagram, you can see the D input is applied to pin number 14 of JK flip-flop. At the same time, it must be applied to pin number 1 of NOT gate. So let's connect. So friends, suppose this switch number 1 is acting as your D input. Now I am connecting this D input to pin number 14, which is acting as J input. At the same time, this input must be connected to pin number 1 of NOT gate, like this. Okay, so D input is going at two places, J input as well as input of first input of NOT gate. Okay. Now the output of NOT gate means pin number 2 is connected with R or in our case K input. So pin number 2 of NOT gate must be connected with pin number 3 of JK flip-flop, like this. Now the input connections are over. Now we have to connect output means pin number 12 with LED. Okay, so LED has two inputs, anode and cathode. So one of the terminal must be connected with a current limiting resistance, which should be grounded. Okay, so I will connect this current limiting resistor with ground like this. Okay, and anode of this LED must be connected with pin number 12 because pin number 12 is our output. So now I am connecting pin number 12 with anode of LED. Okay, so friends, in this way your connections are over. Now we can start with simulation. Before that, remember one thing: if you are using DIP switches, one terminal of DIP switches must be connected with VCC and another terminals must be used as input. Okay. This is now truth table of D flip-flop. From the table we can find when input is 0, output must be 0, and when input is 1, output must also be 1. It means input is same as output. So therefore this flip-flop is also called as delay flip-flop, means we will not get any change in the output. It is same as input. Okay. So let's start simulation. So friends, remember one thing: your frequency should be set to minimum value, that is 1 Hertz. Otherwise, you will not find any change in output. Okay, so right now frequency is 1 Hertz. Okay, now this switch is in bottom position. It means we are applying logic 0 as input. So when the input is logic 0, output must also be logic 0. So here you can notice your LED is off. So therefore your output is indicated as 0. Okay. Now I am changing this. When your input is 1, output must also be equal to 1. So friends, now we can see that when I am changing input to 1, your LED must glow, but it is not glowing. So this is happening because this is dual JK flip-flop and we are using only single JK in this IC. So the remaining pins which are not used must be connected to ground. Okay, and this is your reset input. If we are not using reset input, it must be connected to VCC because it is active low input. So in order to deactivate this input must be connected with VCC. So friends, what I will do, I will connect all the reset inputs, means reset 1 and this is your reset 2 with VCC, and remaining pins must be grounded. Okay. So friends, now you can see both reset inputs are connected with VCC, whereas J, K and clock signal are connected with ground. Okay. Now again we will start simulation. So friends, now you can see our input is 1. So output is also 1. When I am switching input to 0, the LED is turning off, means output is also 0. So for 0 input you are getting 0 output, and for 1 input you are getting 1 output. So in this way we can perform experiment on D flip-flop. Okay. Now let's verify the truth table of T flip-flop. So I will open the block diagram in left hand side like this. So friends, from this block diagram you can see that both inputs are shorted with T terminal. There is no need of NOT gate over here. It means we will not this IC in T flip-flop. Okay, so let us remove the unwanted components, whereas the rest of the connections will remain same. Okay, so just we have to do one change. We have to apply T input to pin number 14 as well as pin number 3. So first of all, I will remove this IC. So friends, now you can see. So this is your T input. Now I will connect this T input to pin number 14, which is acting as J input, as well as pin number 3, which is acting as K input, like this. So now our setup is ready. Now we can start with simulation. So friends, here you can find initial value was 0. So your T value is 0. It means your next state will also remain 0. Means there is no change in the output. Initially 0. After applying clock pulse, also it is remaining 0. So there is no change in the output. Now I will take T is equal to 1. Now your T flip-flop should be in toggle mode. So it should change its output continuously. So make this T is equal to 1. So friends, now you can see your LED is continuously turning on and off, means your T flip-flop is now in toggle mode. It is continuously toggling between 0 and 1 respectively. Okay. So friends, in this way you can perform experiment on T flip-flop. So friends, I hope you have thoroughly understood this experiment. Now, if you do the same connections on breadboard, you can verify the truth table of D-flip-flop as well as T-flip-flop. So friends, if you are having any doubts or difficulties, please drop message in comment section and do not forget to subscribe this channel. Okay, so thank you very much. Have a nice day.